I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project-focused data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au.
Hi, this is Felipe Flores. Today, I'm sitting down with a very special guest, Leonard Aukea. He is the head of machine learning, engineering, and operations at Volvo Cars. Leonard, how are you going today?
I'm doing well, thank you. Very pleasure to be here.
Mate, thank you so much for making the time. I'm super excited to get to pick your brain and talk about all things machine learning, engineering, machine learning ops, applications to cars, how people can better leverage ML ops and ML engineering in their organizations. So I'm very excited for us to spend some time together. Thank you so much. To kick things off, could you tell us a bit about your role at the moment and your remit, what that looks like, and then we'll take it from there.
Sure. As you said, I'm driving machine learning engineering and operations at Volvo Cars. Basically, we're trying to reduce friction along the ML value stream, and we're trying to enable ML initiatives across different domains at the company. And there are some challenges there, so I'm trying to mitigate them. My background is as an ML engineer, data scientist, working hands-on with these things. And that's
amazing.
A little bit about me.
Amazing. Thank you so much. So through the podcast, we sometimes and often do run live webinars as well. And when we do that, we have polls for the audience. And over the last couple of years, over the last 3 years, actually, we've done polls about how many models people have, organizations have in production. And what we find in Australia, at least the majority of organizations have 0 to 5 models in production, with the majority having 0. And then, so we had in the answer, we typically have an option that's 0. Another option is 1 to 5. And then we have 6 to 10, 10 to 20, and 20 plus is how we've structured that so far. And it's basically like 93% of people sit in the 0 to 5, with the overwhelming majority in the 0 category. And then we had some outliers in the 6 plus range, with some very high outliers in Australia, like a couple organizations or a few have over 1,000 models in production. But essentially what that says to me, and what I wanted to ask you, is that doing ML engineering and ML ops is really hard. It seems to be. So my question is it really hard, and why is it so hard?
Well, I think it is really hard, but I think it's mainly hard from a cultural perspective and a people perspective, because it entails a lot of change in the way of working for ML practitioners in general, working in a way they are not maybe in general comfortable with. So essentially it's about adopting some software engineering practices. And also from an organizational perspective, it requires the organization to realize this and make sure these teams have the competencies and the roles required in order to deliver machine learning, production grade machine learning, which I think traditionally has not been the case. So you have a lot of data science teams siloed across the company, and they are sort of responsible to deliver machine learning in production. And I think that's a big reason for failure and why it's hard.
Yeah. Yeah, definitely. So there is a different approach that the data science teams need to take in order to have be able to create products in production and have that industrial strength to the products. What are some of those that changes in mindset and approach that the teams need to do that?
Well, I mean, we had to spend significant effort teaching data scientists to use Git properly to collaborate in teams and get them to adopt like a branching strategy, which lies as a basis for CI/CD and automation and these things. So it basically was starting from scratch. So some of these principles that are well accepted in the software engineering community are basically non-existent in the ML community. It depends, like obviously with more sort of engineering background, and also the scale of the projects themselves. But yeah, it's a challenge, but what we have seen is also like it's not rocket science. These people are smart individuals working on complex problems. So it's about, having an open mind, trying it out, and then over some time we see that this actually becomes more or less second nature to the way they're working. One additional challenge is obviously the dependency towards data. So like in order for companies to innovate and run machine learning in production, it's highly dependent on how they manage and maintain their data. And if you want to get value out of your machine learning products, you need to get value out of you need to have basically good data. And that is also very rare.
Right? Yeah.
Like that. Yeah.
Yeah.
So that's an additional challenge as well.
It's a super tough problem. What are some ways you've seen to get organizations behind having better quality data or focusing on the data component? What are some ways that you've seen that works for organizations?
This is still very challenging for us as well, I must say, but I think one needs to have a business angle on this to tie it to some value and prioritize heavily and be very clear about what this can provide to the organization and tie that story like end to end from to the actual sort of data sources required to build up this at this stage hypothetical value, but it gives you enough backing to invest the resources and time in order to secure data quality and secure those data sources, build out your let's say insights or ML system on top of it.
Yeah, that's great. I love the focus on business value, because if you can nail that, then it'll be easier to get the organization behind improving the data quality. It's always a hard task, and people are struggling with it everywhere. So I'm always keen to pick people's mind on different approaches and how to get it to bubble up to business priorities. And I think business value is a great way to do that. I also wanted to ask you about the differences between CI/CD pipelines from how does the data science or ML CI/CD pipeline, how is it different to the software engineering CI/CD pipeline? Are there any divergences or is it mostly overlap? How does it look like?
Well, it overlaps to a large extent, but it does add some additional complexities. And I think it kind of depends a little bit to like from project to project, and also like organization to organization. But in our case, we track the data and the models and the pipeline artifacts in our CI pipeline, which adds additional complexity. Also, running container workloads, most of these images are quite heavy. Like these are not like small containers. You have PyTorch and other large Python packages managing this dependency hell that is still not nice in Python. So that's an additional challenge. And there are some core differences, since the tests that you're running are also maybe more complicated, and it's not 100% straightforward, but that's not the case either in software engineering, I would say.
Yeah. So where in software engineering they might have unit tests, system tests, regression testing. In ML, we want to have the differential testing. Have a holdout set where we can do a champion challenger approach to our model deployment. For example, and having that test set is completely new for the model when it gets to that point, is something important that I see, at least. But I think so sorry, any thoughts on any of that?
No, I was thinking about maybe trying to explain that differently, but let's continue on, and I might pop into some.
No, that sounds good. For you guys here, having you look after the end-to-end process in terms of it's kind of like you're doing ops across the data pipeline, so the pre-processing and data preparation, and then going to the model creation and creating of new models, and then go into a kind of like a model registry, and then find a way to productionize the models that are winning or that offer an improvement. Is that the landscape for you? Is that a good summary?
Well, kind of. I would say, like, I didn't really elaborate on how we're structured, but we have a central team. Like, it's kind of a small team, but the ML engineering and operations teams work centrally, and we sort of support the different domains. And we also offer the infrastructure and the tooling and the services for running machine learning workloads and distributed training and whatnot. So that's like a product that is part of our deliverable in a sense, and we find synergies between these different teams. And yes, securing that end-to-end machine learning pipeline is something that we're definitely working on, and trying to generalize that to work for the different endeavors. So yeah, that's the landscape.
Yeah, that's great. And your data processing pipeline, where does that end at? Like, do you guys have a feature store? No, maybe you're dealing more with unstructured data. So what's kind of like the handover point between the data processing pipeline to the model?
So we have not implemented a feature store yet, but we're very keen on implementing Feast as a feature store to have this handover. And let machine learning practitioners manage features as first-class citizens. So I think this is a very promising idea and an approach for a large enterprise like ourselves. And we're dealing with unstructured data and structured data, and it depends on where in the company. So we do have manufacturing, we have finance, we have .com, we have the vehicle. So it's all over the place. But yeah, I'm a big believer in a feature store, and I think there's actually more to it, like managing KPIs in a similar fashion as first-class citizens with well-defined KPIs. Like outside of machine learning, there are other benefits, and think about sensor fusion. Like you can see those type of combinations of sensors as a feature. Even though, in that case, it might actually go into a machine learning model. But I think, yeah.
Yeah, nice. So that sounds really good. And Feast, from memory, I might be wrong, but it's an open source product, is that right? Yeah. Okay.
Yeah. We're opting. So we're opting for open source solutions first.
Yeah. Yeah. Awesome. Awesome.
Yeah.
And that's great. That's great. And then so really interesting that you guys service the entire enterprise, providing the systems and the platforms to enable the organization to apply machine learning anywhere and everywhere. Then I might ask you about how you guys do the model creation first, and then I'll move into the deployment and model registry and things like that, if that's all right. But what is the model creation component look like for you guys?
Well, it's part of basically the training pipeline, and you're managing your models basically. Well, I'm not really sure what you mean there. So it's obviously it's a very experimental stage. So you need to give the practitioners the opportunity to manage these experiments and track different parameters, what data has been used to train which model, and do that effectively, and provide them an interface for also doing research and things like outside of the general sort of pipeline to innovate a bit more. But for us, model creation is vastly about training, and we're doing so utilizing Kubernetes container orchestration, and there are some training operators that can be used to train large scale. Although I think even in our scenario, most of the value providing initiatives in terms of machine learning does not require that extreme scale that Kubernetes offers.
Yeah. Great. So I think that definitely covers that component, and then also a bit about the productionization, and then keeping track of how the model performs once it's out in the wild. And then obviously using Kubernetes there. Do you guys use Kubeflow by any chance?
Yes, we use a fork of Kubeflow. The reason for that is because you have this unified user interface that is nice for practitioners. So we have adopted that a little bit for our use cases and added some additional services to it that we consider useful. So, and then also I think the sort of pipeline SDK, or the wrapper around Argo workflows, is quite interesting. It makes it easier for practitioners to write Python instead of YAML, basically. So best of both worlds.
Yeah,
in that sense.
That's great. And what recommendations or what tips would you have for people that want to move into the space of MLOps in general?
Start simple and think about processes and ways of working and cultural aspects, and try to fit tooling and infrastructure along that kind of endeavor. So mainly it's cultural, and you don't need to choose the most extreme state-of-the-art tools for these. There's a humongous amount of startups and a humongous amount of different services that offer MLOps. My personal take there is that I think many of them have, from a design perspective, kind of taken a wrong approach. I think they're user first. They want to sell and they want to show that, oh, we make this easy. So it's about, oh, but you can just write this in a notebook and push that into production, or many things don't really fit the sort of standard good practice of general development, which I believe still is the way to go in order to manage things properly. So you end up working in different ways than, for example, other teams within your organization that you have to collaborate with anyhow, which creates a bigger divide. And then it's harder to sort of apply proper CI/CD practices or running tests on your code. So you end up with, even in certain cases, you don't even end up with a repository somewhere on GitHub. But if you do, it looks not so nice. And well, that's just my take on it. Obviously, I've seen quite a bit because I'm in a position where all of these companies want to sell you something, and I think this holds true for SageMaker and all of those other endeavors as well, to be honest. No, I agree. There's at least in my work in my teams, we definitely had to institute a no notebooks into prod rule, which at the time was not very popular. No,
but it's important, right? So it
is. We actually tried that as well. That was our first approach. Let's try to make this as simple as possible to let practitioners, data scientists push things into prod, automate their notebooks. We use Papermill, read this blog post from Netflix, and we just, but this is great. It's super simple. It's very easy, but what you end up with is a lot of garbage being pushed that is unmaintainable. You don't have complete visibility, observability. It's it was very hard to maintain, and you don't end up with anything even remotely close to production grade, something that you can maintain over time. So we kind of scrapped that, and we went back to let's try to focus on first principles, try to teach and push and evangelize these first principles so that you have good ways of working, and then adopt the infrastructure and tooling towards that and build our CI on top of that. So I think focus on first principles, get that out, start super simple. You need something to orchestrate and run pipelines, and you need a CI tool. So if you choose GitHub Actions, Tekton, or Jenkins, it doesn't really matter. Start with something that you are comfortable with, or your organization is comfortable with. And that's my.
That's great. Yeah, because I was going to ask you what a minimalist or MLOps starter kit would look like. What would be that simple? So yeah, that's what you're saying. Orchestration and the CI/CD component is sounds like the minimal kit, right?
Yes, I would think it is. Yeah.
Yeah, nice. And I think people will be maybe relieved to hear that it's more about the processes rather than a difficult technological challenge. Does that make sense? That the technology, that the ways of doing it is there, but you gotta build the processes and the organizational muscle to do it, right?
Yeah. Yes, exactly. So I think obviously there are technical challenges, but I don't think the focus needs to reside there if you're aiming to like get value out of ML. And yes, there are certain topics within MLOps that are still quite, I would say, like unsolved. If you want to have like complete lineage and data versioning, I think there are challenges there. Like thinking of data in the same way, like let's say as you would use Git, for example, with zero copy, doing that effectively. And how do you manage merge conflicts in data with those insights? Like there are nothing really 100% there, so we're still trying to focus on that challenge. But
I remember when we first, as a data science and ML team, when we first started working with software engineers, we had to really labor this point to say the software, the code can stay the same, but if the data changes, then we're going to get a totally different output. And we really have to work with them and show them examples for them to understand the importance of something like data versioning, which is a bit of a holy grail, I guess, at the moment at least. So I've seen a couple of open source approaches to data versioning. What do you think about those? What are your main frustrations with the way it's done at the moment?
Well, we're currently now playing around with LakeFS, like first and foremost. I think the big player here is like DVC, which works like if you're working on a small problem, or with like the idea is good there. You have pointers and whatnot, but it didn't really scale for us. If you needed to work on like petabytes of data and stuff like that, it was not an option for us. But I mean, many of them are, as we stated, there are some open challenges there that there's no like concrete solutions for. There are efforts that are trying to sort of solve them in good ways. I think design-wise, LakeFS had a good idea and a good approach. So I don't know, there are others out there. I don't remember the name. There's another open source initiative there, but I think they're more or less the same, like slight differences and a different logo, basically.
No, that makes sense. Yeah. So definitely, an open problem at the moment. And especially like when you mix with cloud, because ideally you want your data to stay where it lives, and then be able to be versioned there in a way that's compatible and accessible to the models and the platforms running in the experiments. So there's still a bit of a leap. Sorry.
Yeah, it is. So, I mean, you can get pretty far with some of the sort of features that are offered by the different object store solutions as well. To be honest, you can get pretty far there as well. But we wanted to have a reference in the repository that we could track in a good way, so we can have that metadata. So basically, for each Git commit, we know what data is relevant. So we want to have like a hash for the data, and then a tag for the models and these things. So it just doesn't become nice if you try to scrape that snapshot sort of ID from S3 or something like that. So,
and then even worse, once you get the actual data back that you initially predicted, and you want to feed that back into the model for evaluation purposes, for example, like it just gets even messier.
But this is like part of the complexity of MLOps is like if you want to secure effective experimentation and effective development, you need to be able to, or the practitioners need to be able to compare apples with apples and go back in time and see what actually was done and secure a good method for comparing. Was this approach better than the previous approach? And ideally, even that is automated. Like when you do have good control and good metrics, and you think about those things early on in your endeavor. But yes, it's challenging.
Agreed. And for you guys to get here to this point where you have an ML engineering and MLOps team that's servicing the organization, focusing on enabling across the enterprise, that is quite mature in the journey. And sometimes when we're doing things in an organization, we're always focusing on what we're doing next and the challenges. So it might not feel like, sometimes it might not feel inside the organization, doesn't feel like it's very mature, but I can tell you that in your case, it is a very mature place that you guys are at. So I wanted to ask you about tips on recommendations or learnings from when you guys were starting the journey and kind of like in further phases, if there was any recommendations or lessons learned that you could tell people on how to start this journey or improve upon their journey, and obviously taking the organization with them as you guys have done. What would you say to them?
Wow. So a little bit of how this actually started. So I didn't start off working with ML operations and engineering. This was before the sort of buzzword even came out, but we had deliverables in a domain team, and this was when Volvo Cars was quite early in the sort of cloud journey or something. But I mean, I started off, got handed a computer and expected to sort of deliver value, or like the whole team, and we had deliverables that no, you need to deliver insights on a daily basis or a weekly basis, or you need to train some models or something, and you didn't really have like access to cloud. People were working on their local computers, local laptops. There weren't any tools for like orchestrating pipelines or basically anything. Like it was zero. And I was at that stage quite surprised at that, because I came from a sort of cloud first consultancy. I saw how things were working in a different industry. So back then I was like, oh, we are way behind here. So we need to set something up. So we kind of started that journey to manage our own deliverables, and then other teams kind of jacked onto that. So I kind of feel that what we did was the growth was kind of organic from that. And then we sort of spearheaded our focus. We proved some value. My boss, Ronnie Johnson, was doing a lot of legwork across the organization, promoting, showing how this can be generalized. And he kind of gave us the opportunity to spearhead this and invest more time in building this out. And like what we initially started with was more of, let's set something up that works for us. So that, like, over time, when more teams jump along that, the one notices that, okay, well, doesn't really scale from sort of an enterprise perspective. You need to care about security, multi-tenancy, and all those things when you take on the like full challenge of building up a centralized platform, let's say. So we needed to switch gears and re-architect and redesign a little bit. But yeah, like it highly depends on your organization, but you need buy-in to work on this, and essentially I think action speaks louder than words. So if you can show that this is valuable and to tell a story, like when you're working with data, right? So if you have a story around it, you have some clear insights. I think that's where you can actually, get people to make big impact decisions based on data, where you establish trust and proof of value. That's basically it.
Right. That's great. Definitely the case. And for how did you upskill on the engineering and MLOps space? Because like obviously people can come into this space from multiple backgrounds, and sometimes people come from a more software engineering background, and in your case it was more from a analyst and data scientist background. And how did you make the transition and fill in the gaps and upskill? What was that journey like?
Yeah, wow. It was amazing. I would say, like coming from university, I felt like this piece was definitely missing. Like you were always working with like the terminal, bash, you were working with cloud, needed to access servers, needed to like, for me, like I was hit by like, also I've been a little bit nerdy. So I've liked some of programming, but I have no sort of official training in software engineering, and I still today have some bad practices sort of inherent in the way I'm working, because I came from this Jupyter notebooks kind of scripting just to get the job done from a sort of insights data perspective. But yeah, for me, it's been amazing. Like, it's crazy how much valuable you can become and how much more effective you can become as a traditional data scientist with just some good core knowledge and software engineering practices, becoming a bit better at coding and reusing. So basically just the fact of refactoring some of your functions into a Python module and manage and maintain that in a good way with some tests, so you can reuse these instead of having them scattered across your notebooks and you're just reinventing the wheel all the time. That makes you way more effective. Like
You've seen my code.
Like personal. No, but I'm talking about like personal like experience. Like it takes some time before you like realize, oh shit, I should do it like this. Oh shit, I should do it like this. And then you get excited, you learn a lot more. Like I fell into this sort of, cloud native space, Kubernetes, container orchestration, and like using containers just as a traditional data scientist. If you want to like share your work across, like first and foremost, like I see a lot of data scientists still today that doesn't create a virtual environment to sort of like, how am I supposed to run your code? And we need to collaborate on this particular code, but that's where most of the challenges actually arises. And I think containers are very good for this also, for reproducibility and sharing. And I don't know. It's been a nice journey right now. I'm sort of very excited about software engineering, and I think the cloud native space is very interesting. And I don't know. Like we have the internet. Like I mean, you can you can learn whatever you want, given that you have the sort of motivation to do so, and that's amazing. Like,
isn't it
free
amazing?
knowledge.
Yeah, exactly. The at my day job, I report to the CEO, and my boss, the CEO, he's doing some studies in data science at the moment through the local university, and he's found, obviously he hasn't done formal training in, I don't know, 15 years or 20 years. And he was like, now everything is available for free. He goes on YouTube, he watches lectures from, the best teachers around, and has the blog posts, and has Stack Overflow and code, and notebooks in the cloud. And he's like, this is amazing. So definitely the motivation is there. The sky's the limit, which is obviously something that you've done for a long time now. So I wanted to ask you, what are you particularly excited about in the cloud space and in the software engineering space, and how that ties into the ML area?
Yeah, well, I think, like, running machine learning in production, or most machine learning systems, essentially, like, they are versions of data intensive distributed systems. And when it comes to running distributed systems, Kubernetes is like the main player there. And I think it's very exciting that Kubernetes offers these, like, it gives a nice entry point for someone like me who doesn't have the sort of operations background or running, services and software at that given scale. And it gives you a lot of things for free. It has a nice, well-designed API or a framework which you can extend with your own APIs and other services. It's like an OS for distributed systems. So I'm kind of excited about that. And obviously, sort of the basic ways, the CI/CD options, like automation to make sure you're more effective, the way people care about, like, pushing code into production is not 100% straightforward. You need to care about, like you want to mitigate bugs as much as possible. And I think the ML space needs to care about that even more, given that the sort of you have added dimensions to the search space for potential issues, for like models and data being included there as well. Like, from my perspective, working in ML, you should be extra excited and care about observability, monitoring, CI/CD automations to sort of mitigate some of the issues that we will see and that we see when we're trying to productionize our work. And also, like, I do understand that every practitioner cannot become like hardcore software engineers. Like, even in the software engineering world, you have CI engineers that focuses on CI and these things. It's about structuring the team and finding common ground where you can collaborate and work with people that have these sort of backgrounds. And that's about, kind of a handshake on, like, we all share this same core knowledge at least, and we all know how to use Git properly to kind of write good commit messages, provide PRs that are nice to review, and like, I mean, those type of practices are the things that I'm very excited about, and I think they all lend themselves very, very well to running machine learning systems in production.
Right, I love it. I love the passion. I love the vision, and I'm so impressed with the work that you've done and the amount of ground that you guys have been able to cover at Volvo in this space. It's mate, it's inspirational. So I'm so glad that we got to have this chat today. Thank you so much for sharing your journey, your knowledge, your experience, and I think it's going to be extremely valuable to so many people in the audience.
Thank you. Let's hope so.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.